Hello, everyone. Our talk today is about modernizing Mac provisioning with several Jamf products and Okta. We represent Yelp's client platform team. Yelp is a local services and review platform with around 5,000 employees globally. The majority of devices in our fleet are running Mac OS, but we have small fleets of Windows and Chrome OS devices as well. My name is Albert. I'm based out of San Leandro, California, and I've been with Yelp for a total of 9 years as a member of IT and the client platform engineering team.
Howdy, my name is Michael. I'm from Washington, D.C., and I've been with Yelp for about 5 years now, also a member of IT and the client platform engineering team.
My name is Carlos. I'm from Calgary, Alberta, and I'm one of the most recent members to join the team. I've been at Yelp a little less than 2 years.
Right now, we're a team of 5 engineers managing the security and lifecycle of our devices. And one of the most important aspects of this is ensuring new employees around the globe are able to onboard their devices quickly and easily. With this in mind, today we're going to talk about our journey to modernize our Mac fleet with Jamf and Okta IDP accounts and developing a reliable over-the-air provisioning process for new devices. Of course, no journey is complete without some risks and pitfalls, so we'll also be covering the tale of demobilizing our existing Macs and unbinding from Active Directory. Before we dive into our talk, I'd like to take a moment to give some background on the layered approach we take to device management. To start, Jamf Pro is responsible for device MDM and applying any necessary configuration profiles. To manage user account creation and identity, we're now utilizing Jamf Connect, which we'll talk more about shortly. Where MDM is not required, we love to use open source tools and configuration as code wherever possible. We utilize Jamf Pro as the entry point to deploy our Puppet agent, and this agent gets us the rest of the way to our desired configuration state. Puppet also bootstraps Monkey on our systems, which then stands up the rest of the baseline software required on each system. Monkey is kept fed by AutoPackage, an amazing service which handles automatically downloading and importing software title updates. Backing all of this up is Jenkins, our distributed continuous integration and delivery platform. Jenkins handles integrating and pushing our Puppet code changes, as well as running our AutoPackage infrastructure. I'd like to turn it over now to Michael to tell you where our journey to demobilize our Mac fleet started.
Now, with those bases covered, a bit about our environment. Prior to 2020, we did not need to prioritize a remote-first approach to our Mac fleet, and day-to-day operation had a number of dependencies on access to the corporate network. Macs were bound to Active Directory, a tradition in enterprise. Active Directory provided identity and useful user attributes used for scoping configuration and software. This setup worked well enough, assuming you were physically on-prem or connected to the VPN all the time, which nearly all of our users were. Our provisioning process also had similar requirements around access to the corporate network. This meant IT needed to prep devices in office. Among the requirements was a wired network with access to Active Directory and our internal certificate authority. This was required in order to bind machines and to obtain user certificates. On top of this, we provision hundreds of machines each month, meaning we need physical network ports, lots of physical network ports, which again was not a problem while we were all still in the office. So back to certificates. For anyone not familiar, user certificates can play a part in authentication when accessing corporate resources. In our case, certificates play a critical role in nearly every service the company uses, including network and VPN. In our then current configuration, the device would obtain a user certificate at the time of enrollment with Jamf, which, as we mentioned, required access to the corporate network. This would create headaches often, as users could lose their certificates or have them expire, creating an unrecoverable situation. Then COVID-19 was the thing. Like many folks here, our company had to quickly transition to a completely remote workforce. Our setup, which had previously worked well enough, now had become a major pain point. Users with existing machines could continue working on VPN, but getting new devices into new hires' hands and issuing replacement devices became a real challenge. This necessitated recreating the office provisioning environment at home, with VPN bridges in IT living rooms and stacks of laptops imposing upon linen closets. Inventory, prep, and distribution became a significant hurdle that needed to be solved. While we were still able to continue provisioning new devices, we could no longer ship them at anywhere near the volume we could when we had access to the IT office workrooms. With so many different ways of approaching this problem, we had to stop and ask ourselves, what do we want to focus on to actually solve this? We knew we owed a better experience to our now remote colleagues, and not just our end users, but also our friends in IT who were rapidly running out of closet space to store their blankets and their grandma's doilies. We decided our goal was to offer a completely over-the-air provisioning process, also known as OTA, which would work anywhere with an internet connection. With OTA in place, we would be able to direct ship devices to users, and all setup would happen in their hands at first boot. This would mean we're no longer constrained by the physical limitations of our apartments or the number of available ports in our living rooms. With this goal in mind, we knew we had a laundry list of items to address. We needed a new and better way of providing certificates, a new source for identity, a new way to continue syncing Active Directory group memberships and attributes, and we'd also need to demobilize and unbind a few thousand machines which were already deployed in the field. Oh, and of course, we wanted to do all of this without breaking anything we already had deployed and reusing as much of our existing infrastructure as possible. So, as you can imagine, our requirements around certificate-based authentication were not going anywhere. This meant the first thing on the chopping block was eliminating the requirement for direct access to the internal certificate authority when issuing new certificates. After looking at a few possible solutions, including Jamf's ADCS connector, we settled on the Jamf SCEP proxy as it fit well into our existing environment and offered a near turnkey solution. It's also free with your existing Jamf Pro license. So what is the Jamf SCEP proxy, you ask? It's a service which proxies requests between Jamf Pro and your internal certificate authority, so you don't need to expose your certificate authority to the greater web in order to issue certificates. What's so great about the SCEP proxy is the ability to use dynamic secrets, meaning there's no shared secret living briefly on each Mac during the certificate issuing process. Simply put, the Jamf SCEP proxy permits us to deliver certificates to our end users without them ever needing to connect to the internal network. This also eliminates our chicken or the egg problem, where loss of a valid cert would mean losing access to the corporate network and resources. Along the SCEP proxy road, we had some passionate debates about implementation among our internal teams, but ultimately we had the service painlessly set up. After implementation, we did discover a technical limitation when actually scaling up the certificate deployment with the SCEP proxy. We found our Jamf Pro server was routinely failing to deliver certificates to users, which was odd because in our extensive testing within our team of 5, we never had any delivery issues. As we investigated further, we learned the delivery failures were a result of the default configuration of our certificate authority, which was running Endes, Microsoft's SCEP solution. It was not immediately clear from the Jamf side why these failures were happening, but we were able to determine the root cause by diving into the event logs on the CA. We discovered we were hitting the limit on the number of cached passwords. Endes caches challenge passwords at the time devices make their certificate requests. The default configuration also only allows for 5 cached passwords for each 60-minute period. It would not give out any new challenges until the existing ones had been used or timed out. If a device attempts to perform another certificate request before the 5 cached challenge passwords have been cleared, Endes throws an error and no cert is delivered. This was apparently a fairly common issue, which can be mitigated with a Windows registry edit. In our case, we increased the cap to 1,800 cache requests. Naturally, you can see why this limit never came up in our testing, as there was no way our 5-person team could have hit the original cap. With this change in place, the problems issuing certificates immediately cleared up and enabled us to rapid-fire thousands of new certificates via the Jamf SCEP proxy to all of our end users at once.
Great. Now our certificate situation is under control. So what's next on the chopping block? Active Directory as our identity provider. A big change from our previous provisioning process was a move from AD-bound mobile accounts to local user accounts created by Jamf Connect. We use Okta at Yelp, and utilizing it directly as our new source of identity via Jamf Connect made the most sense. Jamf Connect's integration with Okta made it very easy for us to create local users with basic LDAP information synced to Jamf Pro via Okta. During this move, though, we lost some details about each user, such as their group memberships and extended user attributes. To solve this, we leveraged Okta's API to backfill the lost information. We can't understate how many different combinations of configuration we went through before we found the right combo for us. It really is like a choose-your-own-adventure novel. Next, we'll go over the specific configuration that we landed on. As mentioned, our vendor for identity services is Okta, and Jamf Connect Login has great support for Okta out of the box. In our case, however, we also use Duo for MFA. It turns out the experience of a new hire going through the Duo MFA enrollment flow at first login requires cycling between the native login window provided by Jamf and a web view in order to complete the account creation and enrollment steps. This ends up being a pretty jarring experience for users, so we ended up adopting an unusual configuration to address this. In our case, we falsely set Jamf Connect's OIDC identity provider to ping federate, which is a separate IDP service altogether, while still pointing the OIDC discovery URL key to our Okta domain. This configuration was chosen as ping federate allows authentication entirely within a web view, while also supporting pass-through authentication. This is valuable as it reduces the number of logins required by ensuring that the user's authentication is cached and then passed through to the account creation process. Altogether, this configuration keeps the entire process within a single web view, which provides a consistent user experience with as few authentication prompts as possible. Next up, I'm going to pass it off to my teammate Carlos, who will be talking about how we solved syncing attributes from Active Directory in our new configuration state.
With identity solved, it's time to tackle our missing extended attributes and group memberships. At Yelp, we use Active Directory group memberships for a number of reasons. Two major use cases are automating software distribution and determining each user's desired device configuration state. Since this design had withstood the test of time, there was little appetite for changing it. When bound to Active Directory, a user's group memberships were easily queried from LDAP and cached in a plist via a Python script. Without the AD bind, this fallout needed to be addressed, and a project was conceived. We would continue supporting existing users, fetching attributes from LDAP, while also enabling new unbound users to retrieve the same info using Okta's API. And so, Okta ID Lib was born, a small Python library we created, which allows us to populate all the same AD attributes via Okta, with no local AD bind or LDAP queries required. The way Okta ID Lib works is by executing a read-only query for a user's application groups. Application groups are how Okta classifies groups synced from AD. Lastly, we're happy to share Okta ID Lib with everyone, and we'll have some more info at the end of the presentation. This library could easily be adapted to other providers such as Azure by leveraging the Graph API, and we hope others are able to use and improve on it. As a quick example, the function on the screen is from Okta ID Lib. It grabs all of a user's AD group memberships. The return from the function is cached by Monkey using a custom condition script. Monkey and Puppet then reference this cache when processing conditional items for install and when scoping configuration. Next up, we'd like to talk about how we use what we learned when creating Okta ID Lib to assign administrative rights. Not all users at our organization are granted local admin rights on their Macs, and this is defined by AD group memberships. When using standard SSO integrations, Jamf Connect offers built-in support for managing admin rights at account creation. Typical implementations include 1. Assigning users to role-based app integrations in Okta. 2. Publishing custom attributes to ID tokens. Our decision to prioritize user experience and employ a mismatched IDP profile precluded us from using role-based app integrations in Okta. Next, we looked at publishing custom attributes to the ID token, but this would have incurred additional licensing costs with Okta. Luckily for us, Jamf Connect is flexible and empowers admins with the ability to run logon script. Fresh off developing Okta ID Lib, we figured we could leverage this logon script feature to automatically collect the desired attributes ourselves via Okta's API. Our custom login script queries the user's endpoint by their user ID, which returns the user's attributes. With this information, we can determine if a user belongs to a standard user group and demote them accordingly.
Tying all these efforts together allowed us to completely drop all corp network dependencies when provisioning Mac devices, and empowered us to onboard users from anywhere with a decent internet connection. To summarize, we needed to drop all corporate network dependencies in order to support our new remote employees. To accomplish this, we used Jamf's SCEP proxy to issue certificates without needing direct access to our CA. Lastly, we employed Jamf Connect, which paired with our login script, Okta IDlib, and custom OIDC configuration, let us overcome our account creation hurdles. I'd like to also take some time to sing the praises of DEPnotify. Good user experience is important, and putting nice window dressings on these projects wouldn't be possible without DEPnotify. If you're not familiar, DEPnotify is a great open source tool which is typically used to keep users informed of what's happening during DEP enrollment. Thanks to its open nature, it proved to be a perfect flexible tool for us anytime we needed a guided user experience. DEPnotify. It's not just for DEP anymore. So let's see what our improved onboarding experience looks like from a new employee's perspective.
When a user receives a new device, our IT team has already taken the steps to perform the first boot and allow for the DEP enrollment to complete. In this state, the device has Jamf Connect and the menu app already installed, as well as our OTA package and the login script. At the user's first boot, Jamf Connect login is enabled and our custom OIDC web view is presented. At this screen, users log in with their new Okta credentials and are guided through enabling MFA and changing their password, all within the Okta web view. Once the user's initial login is complete, our pal DEPnotify takes over in full screen mode while we provision the rest of the system's configuration. This first stage of the process is driven by the awesome Install Applications tool. Install Applications allows for dynamically downloading packages and scripts, in our case, from an S3 bucket. This is great for DEP bootstraps as it allows you to have significantly smaller pre-stage packages, which can be easily upgraded as requirements change. We want our users to be engaged with what's happening during this process, so we keep them up to date with useful and sometimes goofy status messages via DEPnotify. After we submit the user information to JSS, we must wait for the user certificate configuration profile to land on the device. During this time, we perform a few additional things in the background. We start by installing the Puppet agent, and then we sync our latest code configuration to the device. Next, Puppet performs the remainder of the device bootstrap, including installing Monkey and all downstream baseline software. Monkey then uses our synced groups to install specific packages depending on a user's group memberships. After this, Monkey pulls all of the software packages from Amazon's CDN CloudFront. I'd just like to mention that CloudFront is awesome, as it offers great performance while also supporting client authentication, keeping bytes safe from prying eyes. Lastly, if users get stuck or if the process hits an error state, our DEPnotify help bubble can send support information to contact our global help desk team. Now we're ready to party. After a user hits the Get Started button, their system is ready for use. So let's discuss some of our takeaways from putting this process together. Straying from supported configurations is not for the faint of heart, but can make all the difference when you know what you want your user experience to be. macOS itself is not without issues, as it became very clear to us with a show-stopping bug in version 12.3, which broke the MFA web view and Jamf Connect, preventing users from clearing the initial login flow. This issue came up just after our IT team had finished prepping a large number of 12.3 systems to deploy, and they needed to retrieve, update, and then re-enroll them with an updated pre-stage configuration to work around the problem.
So we've got provisioning of new devices all worked out and a sweet new standard device state. But what about our now legacy AD bound fleet? It sure would be nice to get all our devices in line with this modern configuration, but how could we actually get users there? And is it too heavy-handed to ask them to demobilize an otherwise working system? As we started planning out how to bring our legacy devices in line with our new remote-first configuration, we received some unexpected help. Microsoft gave us the greatest gift of all, a critical domain controller vulnerability, which, when patched, breaks macOS's ability to bind to AD. Overnight, our legacy AD-bound fleet was cut loose, and demobilization became a need rather than a want. The team was somewhat familiar with demobilization already, but we wanted a way to make this process as great an experience as our over-the-air provisioning process. We knew we wanted to deliver the demobilization experience through Monkey, as our users are already very familiar with the tool. Lastly, it was our goal to ensure this all took place with a single logout and login to improve the user experience and reduce their downtime. Ultimately, we chose to develop an account demobilization tool to help meet these goals. We wanted this tool to be easy to use and minimize the user's downtime as they perform the required steps to convert their account. This tool runs in the user's session as a launch daemon and handles all the logic required to demobilize their account. Having already leveraged DEPnotify in other projects, we knew it would be a great fit for this effort as well. The logic in the account migration tool handles the following steps. First, DEPnotify launches to take over the user's session. Users are then migrated from Nomad and Jamf Connect is installed. Jamf then issues a new user certificate via the SCEP proxy. Following this, we deploy the required Jamf Connect login and menu profiles with account migration settings enabled. We then monitor for the required profiles to be installed, and then when ready, the Jamf Connect login window is enabled via the auth changer binary. Lastly, we prompt the user to log out and back in at the Jamf Connect login window, where pass-through auth handles signing them into the menu bar app. With these steps complete, their account is fully migrated. Finally, we're excited to announce that you can use this demobilization tool yourself as we're open sourcing it. More details at the end of the presentation. Some key takeaways from demobilizing our users. Any process which requires voluntary action from an end user is going to be a challenge. Just think about getting them to perform software updates on their own. Instead, we conceived an automated process that would walk a user through the steps required to demobilize their account. At the end of the day, the demobilization tool was just another item that the user was required to install from Monkey. Again, some thanks are due to Microsoft for accelerating our plans, as this was a project we had been putting off for some time.
Today, thanks to this journey through over-the-air provisioning and end-user demobilization, we are able to provide a great remote-first experience to our Mac users without any of our existing corporate network infrastructure limitations. Although the path we took was full of peril and occasionally self-imposed hardships, it would have not been possible without the support of Jamf and the fantastic Mac admins community. We've included links here to our newly open source tools, as well as all the additional tools we've referenced during this presentation. Hopefully you can adopt them for yourselves and use them in future projects.
Thank you for listening. We hope to see
Thank
you
you.
all at JNUC 2022. Bye.
Hey, thank you for your time. Have a
Thank
great
you.
conference.